Hello and welcome to the Vault of Truth YouTube channel. This is Flat Earth Proof 152. In this video, we're going to be looking at eclipse durations in the north and the south and how they compare. Now for this analysis, we're just going to be looking at solar eclipses. This is a quick refresher of the different types of solar eclipses you can have. It's a total eclipse if the overlap is 100%. It's annular if the overlap is between 90 and 100%. And then it's partial if the overlap is between 50% and 90%. In this analysis, I looked at all of the solar eclipses of the 21st century. There are a total of 224 of them. 114 of them occur in the north, and 110 occur in the south. So the north and the south pretty much get the same amount. The total eclipses, annular eclipses, and partial eclipses are pretty much the same number in the north and the south. As far as hybrid eclipses go, the north has far less, at just 1, while the south has 6. In the next section, we see the eclipse duration in seconds. You can see that in the north, overall, the eclipses take 19,639 seconds, while in the south, they only take 14,419 seconds. This means that overall, in the north, eclipses take 36% longer to occur. And of course, by occur, I mean the time it takes for the disk of the moon to fully cross the disk of the sun. We can see that even though the total eclipses are pretty much identical in number in the north and the south, that total eclipses take 23% longer in the north to proceed than they do in the south. As far as annular eclipses go, even though there's 25% more annular eclipses in the north, they take 50% longer in the north overall to progress. Partial eclipses were ignored in the duration count because their patterns, directions, and coverage amounts vary too wildly from one eclipse to the next. So it's hard to get an apples-to-apples comparison. They can easily be removed without affecting the overall data because they're basically the same amount in the north and the south. As far as the hybrid eclipses go, you can see that even though there's 83% less hybrid eclipses in the north, they only take 60% less time to complete. So it's very clear from this chart of data that eclipses in the south progress much quicker than those in the north. Of course, this is perfectly explained on a flat Earth model. Now, even though we don't know the exact locations and sizes of continents, we can still approximate some of this data, such as the length of the Tropic of Cancer and the length of the Tropic of Capricorn, if we assume that the equator really is 24,000 miles around. In that case, the Tropic of Cancer would be 13,855 miles long, and the Tropic of Capricorn will be 34,145 miles long. Based on that, we can calculate that the sun is moving 577 miles an hour in the Tropic of Cancer and 1,423 miles an hour in the Tropic of Capricorn. Then, due to the fact that the moon moves roughly half a degree per hour eastward of the sun, we can calculate the moon's velocity around the Tropic of Cancer to be 558 miles per hour, and its velocity around the Tropic of Capricorn to be 1,376 miles per hour. With all that information, we can then calculate the speed of the moon crossing the face of the sun in the north and the south. In the south, it would cross at 47 miles per hour, and in the north, it would cross at 19 miles per hour. So you can see here why eclipses progress much faster in the south than they do in the north. Now you might say, why is it that if the sun and moon are moving at triple the velocity in the south, why is that not noticeable and why has that not been measured? Well, the answer is a lensing effect. As you see here, this is a domed glass lens over a map of the Earth with a light being moved around, and it accurately reproduces the sunrise and sunset over the Earth. So there is obviously a lensing effect that's happening in the sky that's causing all the celestial objects to rise and set. So everything we see in the sky is an apparent image, it's not the actual location of that object. This makes it impossible to accurately determine the speeds of any of these objects in the celestial realm by measuring them from the ground. So then you might say, well, how do we know that the different amounts of time for eclipses to progress in the north and the south isn't caused by just an effect of the lens or lenses over the Earth? And I would respond to that by saying, we don't know. It is possible that the difference in eclipse progression from north to south could be caused by some effect or some property of the lens nature of the firmament or firmaments over the earth. But that doesn't change anything. Now we just have two possibilities that explain this on the flat earth, and it still doesn't change the fact that you can't have different eclipse durations on the north and south on the globe earth model. This image here shows how many firmaments the earth supposedly has as described in the book of Enoch. So if this is really what we're dealing with, and there's who knows what kind of mediums in between each firmament shell, the lensing effects could get quite extreme. And without knowing the mediums that are in between these firmaments, what the firmaments are made of, their dimensions, their contours, how far they're spaced apart, without knowing all of this exact data, it makes it impossible to try to model any of this, whether it be a physical model or a computer model, to try to reproduce the way the celestial objects move in the sky. And really, even if we did have all of that data, it would take major Hollywood-level CGI computer software and visual artists to model it, and you'd probably be looking at a cost of millions of dollars. I've personally tried to model this using Blender 3D software, and I pushed the limits of the software, and it just wasn't able to do it. You also have people like Joseph Hanvey that are trying to make physical models of this stuff, but even that is severely limited. And if you really wanted to try to make an accurate physical model of these phenomena, it would really be a major cost. It would also entail a major Hollywood-level production effort. But anyways, the point I'm trying to prove here is that the complexity of the firmaments and the lenses over us are likely far more complex than we realize. In addition, there is no telling how far it is to the edge of the earth. It could be 1 million miles for all we know. There could be thousands of additional continents of land out there, and thousands of additional oceans. Now, I included this testimony from Herv Rabboni that I included in one of my previous Flat Earth proofs about the behavior of sunrise and sunset between the north and the south. As I mentioned in some of my previous proofs, Herv Rabboni is a world-renowned sailor. He's been sailing for decades all over the world. He's sailed in oceans in the north and the south. He's also competed in many world-renowned competitions, so he knows what he's talking about. So here he says, in the north, we have much more clarity before the rising of the sun than in the south. And we have much more clarity after the setting of the sun than in the south. This is because in the south, the sun recedes a lot faster from the observer. We have long summer evenings in the north, while in the south, obscurity comes rapidly. It is even more obvious when sailing because there are no mountains to hide the sun. So, in the northern hemisphere, when you sail close to the summer solstice during summer along the 50th parallel north, we have light a lot longer, and we can even see the glow of the sun behind the horizon all night long. This is something I've never seen in the southern hemisphere at the 50th latitude. So there you have it, a professional's testimony that sunrise and sunset happen quicker in the south. Dawn and dusk come and go quicker. And this matches what we are seeing with the eclipses. So what I think is happening is that the lensing effects that are happening over the earth are causing the rising and setting of the celestial objects to be roughly the same. And these lensing effects are only causing a difference in movement of these objects in the sky when you either get close to the horizon or if you are observing two or more objects moving against one another at certain distances apart from one another or at different altitudes from one another. It is certainly evident that the firmament or firmaments over the earth were designed by a much higher powered being with a much higher intelligence. It is both incredibly beautiful and incredibly perplexing to mankind. The Bible does say, after all, that the firmament shows God's handiwork. So the bottom line here is that the flat earth model provides two mechanisms that explain why eclipses take longer in the north. It is likely a combination of the fact that the sun and moon are moving at a faster velocity in the south, combined with various lensing effects of different firmaments over the Earth. The globe Earth model, on the other hand, has no mechanism that can explain this. We can see in this diagram that shows the major and minor lunar standstill that the moon's orbital plane passes through the direct center of the Earth. Though it is tilted 5 degrees off of the Earth-Sun orbital plane, it shifts back and forth with symmetry. And even though the moon and the Earth orbit around the common Earth-Moon barycenter, they would always do so in a symmetrical manner. And as far as the sun goes, it's shifting back and forth from the Tropic of Cancer to the Tropic of Capricorn due to the tilt of the Earth on opposite sides of its orbit. So this is also symmetrical. And of course, there's nothing weird happening with the spin of the Earth to cause anything. There is a little bit of lunar apogee and perigee shift happening, where there's a slight bit of acceleration and deceleration, but that will be happening in both the northern and southern hemisphere. Also, again, I want to point out that the number of eclipses per century are balanced and pretty much equal in number between the north and the south. So that's it. The globe has no explanation for this phenomena, and we have another great flat Earth proof.